Hello everyone. Today I would like to present our paper entitled BacAnalytics, a tool to support secondary school examination in France. I would like to start with the presentation of my co-authors. They are Associate Professor Azim Russanali and Professor Amboyer, both working at the University of Lorraine in France. The presentation will be given by me. My name is Margarita Alexandrova, and currently I'm a postdoctoral researcher at the University of Luxembourg. Here is the outline of this presentation. First, I will start with motivation, why such tool as BacAnalytics can be required and what it can be used for. Next, I will present the data sets that were used to build our tool. After that, I will present the tool itself, its architecture and the way it is functioning. This will be followed by the evaluation of the tool and its impact. And at the end of this presentation, I will give some concluding remarks and ideas about the future work. Baccalaureate, or BAC, is a high school final examination in France. For those students who don't succeed to pass it from the first time or the first group examination, there is a chance to take a remedial test, also known as the second group examination. During the remedial test, students have oral exams in two subjects of their choice, and they announce their choices on the day of the remedial test. This makes it impossible to correctly estimate the required number of professors for various subjects. That is why the general practice in this case is to mobilize a very high number of professors. The system of baccalaureate in France aims to provide differentiated education. That is why there are different types of BAC. More precisely, there are three of them. They are general baccalaureate, technological baccalaureate, and professional baccalaureate. Students sitting for professional baccalaureate are prepared to enter the labor market almost immediately after their high school completion. At the same time, students taking technological BAC or general BAC usually continue their education as high technicians or at the universities. Every type of BAC has different streams and various specializations. These streams and specializations differ in the subjects that are taught and the associated weights that are used to calculate the final passing grade of the student. For example, general BAC has three streams. They are scientific, economics and social sciences, and literature. As we can see from this table, the scientific stream puts higher emphasis on hard sciences such as mathematics, physics, and chemistry. At the same time, economics and social science emphasizes more such subjects as history and geography, philosophy, while keeping math being quite important as well. And finally, as expected, the literature baccalaureate have high grades for the languages. All this makes the system of BAC quite complicated. Finally, this figure shows the total number of students in France registered for general baccalaureate or technological baccalaureate in the years 2018 and 2019. In red, we can see the proportion of the students who took the remedial test. As we can see, these numbers are quite high. For example, for general baccalaureate, it is around 14.5%, and it reaches 17% for technological baccalaureate. All this makes the task of managing the students being quite important. If we could only predict, at least approximately, which subjects will be chosen by the students, it would have helped us to organize the remedial test more efficiently. In order to do that, we cooperated with an institution that is responsible for the organization of BAC examination in the Lorraine region of France, with the Academy of ISMIS. Academy of ISMIS provided us with historical data sets about almost 11,000 students that had to pass the second group examination between the years 2013 and 2017. After that, in 2018 and 2019, BacAnalytics tool was evaluated in the field. That means it was used to assist in the preparation of the remedial test. And In both of these years, almost 3,000 students had to pass the second group examination. Let us have a look more precisely on the data set that we worked with. First, we have general information about the students. This is the student ID, the year of the BAC test, the type, stream, and the specialization of the BAC. Next, we have the associated geographical center, that is the geographical place where the exam will take place. Finally, we have the two choices that were made by the students, that is the two subjects that were chosen with the associated corresponding grades. Additionally, we have information about the student's performance in the first group examination. That is, for every student, we have a list of subjects that he had to pass and the corresponding grades. Using this historical information about the performance of the students in the first group and the information about the type of the BAC, our tool, BacAnalytics, aims to predict the two choices that will be made by the student. Let us now have a look on the inner structure of the BacAnalytics tool, that is, on how this tool is functioning. As it was said on the previous slide, we use historical information about the performance of the students in the first group examination and the associated BAC type to predict the choices. So, the historical data is used to train a prediction model. In this work, we used random forest classification model, however, other prediction models can be also used. After that, using this prediction model, we try to predict the choices for the students of the current year. We refer to this step as step 1 prediction. Usually, the output of the classification model is only one classification label. However, we need to predict two possible choices. That is why we use top n most probable class labels to predict the choices of the students. In this work, we experimented with two possible values. That is, we used top 2 most probable predictions and top 3 most probable predictions. And we will discuss the functioning of our tool in these two scenarios later on. Let us consider an example of step 1 prediction. Here we have information about 12 students. All of them pass technological BAC and the associated stream is STMG. They are distributed between two geographical centers and they are predicted to choose two of the 4 different subjects that are represented in different fonts in this table. As the number of predicted choices is 2, in this case we used top 2 most probable class labels to obtain our predictions. Next, we perform a step 2 prediction on which we do aggregation by centers and by subjects. Indeed, BacAnalytics should predict the number of professors of every subject for every geographical center. How this aggregation is performed? Essentially, for every geographical center and every subject, we calculate the number of times it was chosen by the students. In this case, for example, this first subject, Gestion financière, was chosen 3 times in the first geographical center. Indeed, we have first choice, second, and the third one. Next, we finalize with the step 3 prediction, during which we do aggregation by professors. What it means? Essentially, every professor has a limit in terms of how many students he can examine during a one-day examination session. In order to obtain the result here, we divide the result of the step 2 prediction over the number of students each professor can examine, and we round the corresponding result to the closest higher integer. Let us assume that the professors of all these subjects can examine 4 students during the day. Then, in order to obtain the results of the step 3 prediction, we'll have to divide the entries of this table over 6. In the first case, here we will obtain 0.5, and after rounding this value to the closest higher integer, the corresponding prediction of the number of professors will be 1. Additionally, we ensure that there is at least one professor for every subject in every geographical center. That is why we'll predict one professor of French in the second geographical center as well. However, despite of our prediction that no students are going to choose French in this geographical center. On this slide, we will discuss the metrics that were used to evaluate the performance of our tool. Let us consider an example of step 3 prediction, where we are required to predict the number of professors per every subject in every geographical center. In this column, the first column, we have the number of predicted professors. In the second column, we have the real number of required professors. Using these two values, we can calculate the number of correct predictions by taking the minimum between the two corresponding columns. After that, we can sum up all these values and obtain the total number of predicted professors, the total number of professors required to be predicted, and the total number of correct predictions. We use accuracy and redundancy in this work. Accuracy is calculated in the following way. It is a fraction of total number of correct predictions to the total number of professors required to be predicted. Redundancy is calculated as a fraction of total number of incorrect predictions over the total number of predictions. The number of incorrect predictions is calculated by subtracting the number of correct predictions from the total number of predicted professors. Due to time limitations, in this presentation, I will present only the evaluation of the final step 3 prediction or the per professor prediction. In these two figures, you can see the accuracy and the redundancy for different streams of technological and general baccalaureate that were considered in this paper for the year 2018. We consider two evaluation scenarios. The first one is the top 2 most probable predictions, when for every student we predict 2 possible choices. Accuracy in this case is presented in blue color and the redundancy is in orange. We can see that sometimes we can achieve quite high accuracy, almost reaching 100%. However, the lowest accuracy values for this case are only 90%. That indicates that probably in such scenario the system is not good enough to be used in practice. That is why we also considered the second scenario, top 3 most probable predictions, when for every student we predict 3 possible choices. The accuracy in this case is in green and the redundancy is in red. We see that in this second scenario, we achieve 100% accuracy for almost all streams, except of the STMG stream of technological baccalaureate, where the accuracy value is only 97%. The mean value of redundancy for this scenario is approximately 25%. These results are already good enough, and it indicates that such scenario can be used in practical evaluations. The corresponding results for this scenario for the year 2019 are shown in this figure. We can see that again, for most of the cases, we achieve almost 100% prediction accuracy. STMG stream is still the most difficult to be predicted, and in this case, the accuracy drops to 95%. Despite of the fact that accuracy is not always 100% correct, BacAnalytics tool was highly appreciated both by the users and by external commission. In particular, users noted more peaceful atmosphere and controlled exam organization process. Additionally, the tool was awarded French National Prize in Nomination Innovation. To sum up, in this work we present BacAnalytics, a tool to assist in baccalaureate remedial test organization. This tool is based on historical data and it can achieve almost 100% accuracy with approximately 25% of redundancy. It was successfully used in the years 2018 and 2019, and it was awarded a French National Prize. However, the evaluation results show that probably the results can be improved. In particular, in future, we would like to concentrate on the difficult cases by building more specialized models, by using more data, and by incorporating feedback both from the model and the users.